Well, let's look in Chapter 18 at the ADT class first. We'll do the abstract data type, the static stack. Remember, the static is the one that's of limited size and is implemented as an array. Let's go look at a program, 18.1 in the book. And it's really just a simple demo program. It includes the intstack.h file. And since that is a not a template file but a regular file, then we have both the .h and the .cpp. We made a variable to hold values when we pop them off the stack. You have to learn new terminology here in Chapter 18. We pushed them on the stack and popped them off the stack. And if you look in your book in that explanation, you'll see that there are several, in Table 18-1 and 18-2, there are member variable names that are assumed to be used in the ADT class, and then member functions, the constructor, destructor, is full, is empty, pop, and push. We will have to learn some more later, little bit different, very similar. So anyway, we define an object of type int stack called stack, of size 5. Remember, we're implementing this as an array because it's a static stack. And we're just going to display a message out to the user, be polite, pushing 5, and then to the stack we do the push method and send it a 5. And we'll do that 5 times. And then now we'll pop them off. We'll start with the beginning message, and then we'll pop a variable off the stack, remove it, and catch it in catch variable, and then display it out. We'll do that 5 times. Okay? Remember, I said to you that the point in these programs is that you in most of these main programs, you're just demonstrating that you made your well, this is a stack, your class work, whatever the class is. So here in the intstack.h, we have an integer pointer called stack array. Where did I get that? Out of the book. And then an integer called stack size. That's also in the book. It's in the library there. And then an int called top to show us where the top of the stack is. And remember that you have the stacks are like the plates when you go to the store, to Old Country Buffet or Golden Corral. They're last in, first out, and so you have to watch the stack. The top of the stack moves down as you put more variables in it. So anyway, we have a constructor, and we have a copy constructor, and we have a destructor, and we have a set of member functions that were already declared for us. Notice that when you push, you're just pushing on the variable, but when you pop, you're popping off by reference, because you don't want to pop off a copy. You got to do something with it. You want to get it off of there, so you pop off by reference. And then in the CPP file, there's a constructor. And notice that, we're keeping track in an array, so our top of our stack is going to start at -1, so that when we push something onto the stack, we'll be at 0. Pretty tricky, eh? And then we have a copy constructor that's going to get the original of whatever the other one is, and then if the stack size is greater than 0, if there's something in it, then we'll make a new stack of the same stack size. Otherwise, don't make anything. And then into our new stack size variable, put the size of the other stack, and then copy the contents from count to 0 to less than size by 1's copy. It's the same as a copy constructor we did in Chapter 14. Same thing. And then we have to reset the top of the stack. So from the object we got in, wherever its top is, we put that in our new top. And we have a destructor. And then here's a push. So first of all, if your array is full, if is full, then say, sorry, you're out of luck, stack is full. Otherwise, increment the top, so we're moving the top, and then into the new top, the next item element in the array, put the number that we got in from the user. And then for the pop, we're going to expect to get whatever the value is at the top of the stack, pop it off, copy it into the variable name that was passed as when we called the function. See here when we called the function. See, we called the pop and we sent it like catch variable so it would know where to stick it. So we got this variable, catch variable, by reference, so we have a place to stick it. And then if the stack is empty, we'll always have to do this data validation. If the stack is empty, then say so. Otherwise, then into that catch variable that we're calling num here, take the value that was in the top of the stack array as we moved along through the array, and then decrement the top. Now, getting the picture in your mind is probably a little bit tricky. You have to find a way in your mind to figure out how you're going to visualize tops of stacks. But if you get confused as you're going through, that's why. It is a little bit confusing. That's the confusing thing in this chapter, is just that. So anyway, so here is our isFull function. We're not going to make any changes. So we'll set a bool called status. And if the top is, if it's full, okay, we have an array size of 5. So if top is stack minus 1, which would be 4, our stack size is 5. But if we get to element 4 of the array, then we'll say isFull is true. Otherwise, if it's not, then we'll say isFull is false. Oh, look, I see a typo. That's not my fault. I didn't type that from the publisher. I guess it's not the first one. And then here's our isEmpty function. So we'll set the bool. And we'll say if top is minus 1, then status is true. Otherwise, status is false. And return status. The others are very similar to this. Little differences in the way they're implemented, but that's the idea. That's why I spent 8 minutes here. Spent 8 minutes on this program to get you the idea, to get you started.